Hey everybody, Dave Lindbergh in Hong Kong with another episode of THD Podcast. Thanks for joining us. Today, joining us, we have HEAD Acoustics, a company founded in 1986. They do test and measurement on black box systems. And specifically today, we're going to talk about measurement of ANC headphone applications. So joining us, as always, is our co-host, Simon Weston in Japan. How are you doing today, Simon?
Very well, Dave. Nice warm weather at the moment.
Great. And Jacob Soendergaard from near Cleveland. We won't disclose his location because he seems to be an important guy teaching the world with these funny little humanoid test devices that you see in Amazon labs and all over the place. Jacob, thanks for joining us today.
I'm happy to be here. It's nice to see you guys, Dave, Simon, and I'm happy to be on board. And I'm excited to talk about ANC headphones today.
All right. Well, before we get too far down the road, we got to thank our sponsor. It's the Alti Association, and Barry has requested that I plug his upcoming trade show. So October 24th, 25th, everybody get vaccinated and get yourself down to Florida to check out what's going on at the Alti Expo. So now that all the business side is out of the way, so Jacob, this company, HEAD Acoustics, it's a German firm founded by Klaus Genut. Is that how you pronounce his name?
Genowitz.
Okay. Okay. In Aachen, Germany in 1986. So tell us a bit of the backstory. I mean, you guys are in a lot of different markets, so let's quickly kind of discuss the different markets, and then we'll get on to focusing on the ANC stuff.
Yeah, the genesis of the company starts with Dr. Genowitz, and back in the mid 1980s, when he had I think it was a PhD project in association with Mercedes-Benz, and this is in the early days of vehicle development in terms of sound quality and sound perception, and attaching that element to the overall quality perception of the vehicle. So no longer just miles per gallon, horsepower, yada, 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 the mechanical specifications of the car, but also that sense of luxury and quality. And that's really where sound and audio and acoustics comes in. And that's where HEAD Acoustics came into the picture and onto the market. So that's the genesis of the company. But since then, the company itself has really split itself into two mini divisions, one focused on sound and vibration and perception, and the other one a little bit more on telecommunications and audio. So we work together. There's some overlap, but there are two separate divisions. And the group that I'm in is focused on telecommunications and audio. So one of the things in my purview and under my domain is ANC headphones. Mm-hmm. And, as we know, ANC headphones has been around for a while. Simon, you worked with them extensively in your career. But one of the things that really make them unique from our perspective is the fact that ANC headphones today are much more than just an audio playback device, right? They're integrating so many more components, a microphone for one, which these manufacturers have taken advantage of for more than just ANC. And so, HEAD Acoustics has a very long and rich background in psychoacoustics. Mm-hmm. Where we feel ANC headphones, amongst its multiple applications, there is a need and a demand for applying psychoacoustics to better correlate some of the tuning parameters with the subjective experience that the customers ultimately end up having. And so It's something that will help the developers move along. And I remember an anecdote that Dr. Genowitz shared at a dinner a couple of years ago when he was last in Detroit visiting mm-hmm. HEAD Acoustics Incorporated, the U.S. Affiliate. And he said that trying to judge the quality of sound using a single number, like dBSPL, is a little bit like a waiter serving you a bowl of soup and you being dissatisfied with the quality or the taste of the flavor of the soup, and the waiter saying, well, at least it's the right temperature.
Right.
So judging the quality of the sound and the quality of the experience using that one single number, make that a little bit akin to saying, well, our ANC headphones offers X dB of attenuation. Yeah, but it just doesn't sound right. How are you measuring that attenuation? How does that relate to the subjective experience? And there's so much more to it than just that. So I don't want to talk about soup, but I want to use it as an analogy for ANC headphones and the need for psychoacoustics.
Yeah, I've seen some of your other stuff, and I've seen you use that analogy a few times, and I akin it to I was a DJ for 20 years, and I remember some of the more egocentric DJs. It would be the same rig, same equipment they had to perform from, but one guy had to have a blue light, or he couldn't perform. So it's like, but these are the things, like what makes the experience for that user different. So anyways, that's a little bit of an off-the-wall example. But I think one of the themes is that the relationship between the test scores of measurement and audio. I've had other acoustic engineers like Tim Whitwell at Tectonics explain to me once, is that, it's 95% science and 5% kind of magic and know-how. And so is that kind of the principles of where you're drawing in? You're trying to quantify some of these psychoacoustics, aren't you?
Yeah, I mean, we're trying to close the gap between science and art. And, the last X%, I don't know if I'd go 95.5, but there is some X% that's definitely art. And, there's a big difference between what an FFT analyzer would judge as being a sufficient, let's go ANC reduction, and what a human ear would judge as being appropriate and pleasing and satisfactory. And so that's where psychoacoustics comes in, right? We still rely on an FFT analyzer to take data for us, but fundamentally, the human hearing system is not an FFT analyzer, right? We're actually more akin to a time waveform analyzer, the human hearing system. And so we also have to consider things like transient events in the time domain, which in terms of FFT, that just doesn't take place. And so that's also why we need to rely on some more sophisticated metrics beyond just looking at a spectrum and an overall dB attenuation number. We have to consider the time domain. We have to consider hearing models and psychoacoustic metrics, and even things like jury study results, and the associated mean opinion score, MOS metrics, that can be developed from those jury studies.
Yeah, I suppose, the human ears are adaptive. So it's like going to a Metallica concert. The first note they play is blaring, but after 20 minutes, you don't necessarily, well, you should wear hearing protection, but you know what I mean. You adjust to those sound levels over time.
Oh, absolutely. I'm glad you mentioned, I use a different example when I go out and talk to people about the human hearing system. And the one I typically use is if you're sitting in a quiet room, we're all in relatively quiet environments. Before this meeting kicked off, if you had a loud air conditioning unit kick in, all of a sudden, you're totally aware of that air conditioning unit. But as this thing just starts humming along, it sort of fades into the background of the human hearing. So it doesn't go away using an SPL meter. It's still there, but you adjust to your surroundings, right? And so not only is the human hearing system more of a time waveform analyzer, it's also a differential acoustic pressure analyzer. We're looking for changes in sound pressure level more so than absolute levels.
Right.
And those are some of the things that we have to consider when we look at ANC headphones. And, if you want to just take a little bit of a dive into the actual ANC headphone, I think the three main topics that we want to look at are going to be how, ANC headphones perform in terms of purely just blocking out the noise around it. That's sort of the core use case of ANC headphones when they sell them and promote them. That's, you just want to be in your own little acoustic bubble, isolated from the rest of the world. But then they're also, the manufacturers of these devices are also taking advantage of the fact that you have a microphone on the outside of the headphone, or two or more, to offer what some people call a transparency mode or a talk-through mode. Which, depending on the brand and the tuning job they've done, can sound really, really incredibly well, and then in other cases, really awful. And that's one of the things that we have to look at and consider when we're designing this device, because it really affects how the users perceive the quality of the device. And then the last one is, they have a mic there. If they're paired up using Bluetooth to a smartphone, they have every capability in the world to handle voice calls, communications, Zoom calls, Teams meetings, what have you. So for more of the professional business user. And so, when people talk about audio devices and headphones, and you go back to Floyd Toole and his statement that, a frequency response is the single most important aspect of the performance of any audio device. If it is wrong, nothing else matters. That's as a quote from 2009 from Floyd Toole. Mm-hmm. That's correct, but I think the premise of this discussion is it enough? Is it enough to just characterize an ANC headphone based on its audio playback frequency response? And our argument is no. And when we start to analyze all of these different, the multiplicity of ANC headphones and all the different basically segments that it tries to address with this one mm-hmm. device, you also have to draw on additional tools. And as we call them psychoacoustic tools, but it's really just a way to really correlate acoustic and audio events to the subjective experience and the human hearing experience.
So I do notice there is this aspiration for ANC to become adaptive so that they'll be able to, on their own, adjust to, going through a metro station, onto a walking path, and it would be adjusting as the different outside noise is coming at you. And then also, like you said, the transparency modes of adding, like in traffic. I thought there was a bylaw passed in New York one time where you had to have that functionality for bypass in ANC. I'm not sure if that's accurate, but you can imagine applications like that anyways, where it is important. But then, I mean, looking at your kind of test setup, so you guys basically have somewhat of a room where you guys would set up your test fixture and then running in all these scenarios of the park, the metro, the traffic situation, and you're simulating that. Can you tell us more about that?
Yeah, absolutely. So, again, with ANC headphones, there's been, certainly in the early days, an over-reliance on using something like pink noise as mm-hmm. a nice broadband stimulus. You can, stimulate the entire frequency range, and you can try to characterize the performance of your ANC headphone. Unfortunately, what we found is that it just doesn't correlate well with real-world performance. And in some cases, maybe because pink noise has been used extensively during the design phase, you get an overestimation of the ANC performance. So some devices mm-hmm. perform really well using pink noise. It's nice, deterministic, it's flat. You can really, tune your device on how to handle that. But once you get into the real world, we talked about all the transient events, going from a metro station to a park, to a high traffic situation, to a cafeteria with babble noise, human speech. Mm-hmm. That's very different than pink noise. And all of a sudden, the headphones have to behave very differently in order to adapt to those environments. And so one of the core things in our test setup and how we approach this is we have to be able to go out and record those real world events and then bring them back into the lab and be able to reproduce those events realistically so that the designers have access to these environments at the click of a button, and preferably in a completely automated fashion, right, in a bit accurate fashion, so that when they hit record or playback, it starts at exactly the same time. So if they start messing with their ANC tuning algorithms, choice of microphone, packaging, what have you, the changes in results that they're seeing is not due to some random overlay of audio playback and background noise. No, that's all synchronized and bit accurately played back. It's due to the efforts and the changes that they're making, good or bad, but it's due to the effects that they're implementing onto the device. So the background noise reproduction system is actually something that's been adopted in the telecommunications world for a while. So there's an ETSI standard, TS103224. It's free to download. People can go look at it if they want to get the math behind it. But the idea is you go out and you use a 8 microphone array to record different background noises. And then when you get back to the lab, you use the same 8 microphone array to equalize a sound field generated by 8 loudspeakers. So you take out all the non-linearities of your room and the loudspeakers, cabling, amps, what have you, and then uses some pretty sophisticated math to get not only the amplitude, but also the phase information correct relative to your room conditions. So when you hit play on that 8-channel recording you did at the park, it's going to come back, and then right at the sweet spot where you've equalized your chamber, which in this case is going to be right around the ears because that's where a device sits, it's going to sound exactly like it did out in the park. So we have this ability to bring the real world back into the lab, and then start to test, well, how does the ANC headphone actually perform when you're sitting, back in the days when we used to fly around, all this, airport lounges was a big one, right? Especially when we talk about talk through mode, you want to hear the announcement, gate, whatever, flight's leaving, got to book it now, right? You got to have that ability. Airport lounges maybe not as relevant right today, this moment, but other applications for sure.
Is there, like, I know in like machine learning applications where you're trying to get kind of a line of fit across all the environmental noise applications, is there a certain number of samples that you get to get an averaging of what things would be, like in terms of like a cafeteria, like would you record for several hours and then pick out like would you normalize a noise out of that, or would you just run a loop, because it could fluctuate within the time, right?
Yeah, and that's a good question, because like you mentioned earlier, the ANC systems are getting a lot more sophisticated, and there's some adaptation time and convergence time that you need to take into account, but generally it's relatively quick. And so the samples that we would use are typically recorded somewhere between 30 and 45 seconds worth of background noise that we can then continuously loop if we need to. There's some smoothing filters right at the end, so we don't end up with a weird step and a jump as we loop the file. But that's generally enough, and if you have to do 1 or 2 iterations, that's fine. But you don't need to go for hours and hours and hours during a testing phase. Just capturing that and maybe looping once or twice is enough to give you the data that you want for each individual test case, for each individual parameter. There's a few different parameters that we want to test.
I'm just brainstorming off of this, because I know there's some edge computing ICs out there that have the ability to preload, like in neural decision processing, like a lot of data on a very low power IC. So those could be very cool for like adaptive noise canceling applications, in terms of they would be able to have a good sample size to predict what the noise canceling should be for that user. Okay.
Absolutely.
So I'm looking at the diagram for the test setup for ANC with 8 speakers around it. And this for me is the key point, because I see probably a vast majority of people designing ANC headphones use one speaker on axis and say, look, I got 30 dB peak. And you take a real measurement with more of a diffuse field or sound originating from different origins, and it's nowhere near that figure, and their user experience is much less than that too. You've got any more comment about that?
I think I'd rather talk about what can be as opposed to what has been in the past. And you're right, it's been a very clear limitation. One of the reasons with the one loudspeaker on axis, and especially with something like pink noise, we have data to show that it's just not realistic. And instead, drawing on international standards that have been adopted in adjacent technologies like voice and communications and applying it to ANC system, it makes the world of sense to us. And especially when you talk about something like ANC headphones that has the capability of making voice calls, it's probably a domain that they need to address anyway. So the capabilities are there to address the multiple elements of it. And I think that's probably as far as I go. But it's something that we're very keen on and very high on at HEAD Acoustics, is using accurate real world noises that can be reproduced accurately in the lab.
Excellent. Okay. And do you provide that complete setup for your customers?
Yeah, we have turnkey solutions for all this. And, the background noise is one of the key tenets of the system. The other thing, of course, is you need a head and torso that represents the human being in the sound field wearing the headphones. We talk about using pinna simulators. Those are the outer ears, the fleshy bit of the ear, as well as the ear canal and the inner ear simulator, which is more on the acoustic side, the transfer impedance of the human ear. Those are all important elements, and we have head and torsos that can address that field. And then when we get into sort of these adjacent applications, especially in the talk-through mode, you're going to need a secondary talker, because crudely speaking, you can break down that talk-through mode or the transparency mode into 2 different applications. You're sitting somewhere, you have your transparency mode on, and you're either trying to listen to a PA system making some announcement. Maybe you're on the bus and it's like, hey, next stop is going to be whatever square that I need to get off at. Super. I heard it. I can get off the bus. Or somebody's talking to you. My favorite example was a flight attendant comes down the aisle of the airplane and asks if you would like something. Well, you're fumbling with your headphones and did you hear that or no? And, transparency mode, you heard it perfectly. You can just respond and continue your conversation and get back to whatever it is you were doing. That's the ideal case, right? But then from a test setup, we're going to need an external or a secondary head and torso that's the talker, because there's a very big difference in terms of directionality, the sort of the spray pattern of a head and torso versus a PA system and a loudspeaker. And so we need to simulate that. It's all about just replicating the different environments in the lab and controlling those environments.
Is the fundamentals of the transparency mode, would that be, and it's ignorant, but is that similar to what the hearing aids use for kind of there's some like Oticon and people like this have the ones where you can focus on a speaker, somebody that's speaking to you. And so is the test system similar for those hearing aids as it would be for the talk-through modes?
Yes. The mode there with hearing aids, they're specifically, I think the example that you're alluding to, they're specifically trying to address the cocktail party effect.
Exactly.
The human brain has the ability to filter things and essentially beam steer our hearing based on our attention. And for a hearing aid user, if the hearing aid isn't designed correctly, you're just getting all the conversation in the entire room pumped into your ears, and it's just incredibly hard to filter it out. And so they're using things like beam steering to focus on, you have different modes. You can have the face-to-face, or I think even side-to-side if you're sitting at a long table, for instance, and then sort of an omni mode. So the hearing aids have different modes to address those different social interactions. And they would use a similar test system exactly because they would need to be able to replicate those scenarios as well in the lab. And we feel like that's exactly the same for ANC headphones. Although I will say a lot of the ANC headphones I have seen, they really only offer a transparency mode or not. It's a binary, it's on or it's off. Some are experimenting with a little bit further, but going so far as to say, hey, it's beam steering, it's focused one way or the other. I haven't really seen that quite yet for commercial off-the-shelf products that offer transparency mode in the consumer audio world.
Right.
But, I'm sure you guys have seen the trends as well with the hearing aid companies, especially the big 6 hearing aid companies are partnering up or even purchasing outright some of the audio and, the consumer audio groups and divisions from around the world. Was it Sonova and Sennheiser was a recent headline.
Yeah.
And it makes a ton of sense that they each borrow from each other. They're essentially going down the path of creating what I would call a hearable device.
Yeah, and I think like Bose did hearing aids announced this week, and also companies like Nuheara out of Australia offering hearing assist devices, and that's their focus as a consumer product, but with hearing assist. And even the AirPods are pining towards servicing that category with transparency mode and hearing assist type functionality.
Absolutely. So there's some good synergy in the industry, and people are throwing a lot of money behind this. And before these markets get into these products get into the hands of consumers, our big plea is please test them properly. Otherwise, they're not going to fare very well, and the consumer is going to have a bad experience. Okay. And so I think that's when we go back, and if we look at something just like the pure ANC application where we just want to attenuate as much as possible, of course, our system can measure the dB attenuation in terms of a single number. Of course, we can report that. Of course, we can break it down and we can look at the spectrum of how the active portion of the ANC headphone performs versus the passive, and then the total attenuation spread across the frequency range. But is it meaningful? And I think that's where we really need to consider drawing on some of the psychoacoustic metrics. And so a simple one to use is something like Zwicker Loudness. There's a newer one, more Glasberg is another one. Whichever one you really go for, I think the encouragement from our side is please consider adopting something like hearing models. And hearing models takes that next step. In the case of Zwicker, it's still only a frequency domain based hearing model. So there's a lot of transient and time domain information that doesn't get considered, but we still take that one step further beyond just an FFT analyzer. And we start consider things like masking effects in the human ear, spectral sensitivity. So going back to like Fletcher-Munson loudness contour curves, where the human ear is more sensitive in certain ranges, like 1 to 4K, where you have fire alarms designed because it's just piercingly loud right there, versus down at 20 hertz, 50 hertz, where we're not very sensitive, likewise at very high frequencies. So Sprecher Loudness takes some of these things into account and then starts to model and present the data on a scale of subjective magnitude as opposed to just absolute magnitude. And so that's kind of a first initial step to say, okay, we had X dB of attenuation, but in terms of loudness perception, how much do we actually reduce that signal that is now measured at the eardrum of the head and torso?
Yeah, those loudness perception metrics that you just mentioned, is that a number that's computed automatically by your test system from a measurement?
Yeah, so I mean, we in the head acoustics domain, our Aqua test system has that option available where it's just a psychoacoustic option that gives you access to all these different metrics that we've implemented in our system. But they all date back. There's some ISO standards, ISO 532-1, for instance, that specifies Sprecher loudness. Or Glasberg, I think, is 532-2. So there are international standards behind a lot of what we do and behind a lot of what we apply here. I think, some of the novelty is a little bit taking these technologies that have been used in slightly different domains and adjacent domains and applying it to ANC. And the encouraging thing is that when we take very known headphones and we look at our data and we compare it with the subjective reviews that a lot of people post online, kind of the beautiful thing is that a lot of the psychoacoustic data and a little bit more advanced, like the Moss metric data, correlates really well with the subjective experience, even when the sort of the simplistic analysis, the dB attenuation numbers don't necessarily correlate, neither with the subjective nor with the psychoacoustic data. But the subjective and the psychoacoustic data have a very strong correlation. And I think...
I think at the beginning you kind of touched on adding these psychoacoustic metrics, and it was a lot to do with taking it from this 95% science to 99% science. So, okay, now it kind of makes sense to me. All right, it's a little more clear now. Adding extra test metrics or bringing in standards from other, like you say, kind of parallel industries to round out the measurement qualifications.
Yeah, that's exactly right. And there's still going to be some art involved in this. We can't completely nail down everything. There's also an element of psychology that we're unable to map at this point, right? Trust me, if we could, we would. But, we could both listen to the same piece of music and there's something in our individual backgrounds that stirs an emotion in us that's going to be separate. And that dives into the psychology of human sound, which isn't quite covered in this, but at least from the psychoacoustic portion, we get that one step further and beyond what just an FFT analyzer would tell us.
Yeah, like people that are into stuff like Philip Glass or stuff like that, if you know who that is, like just nails on a chalkboard is somehow appealing to some people. Maybe we could jump into the topic of voice call performance and how that interacts with the head.
Yeah, absolutely. So, the idea, of course, is with ANC headphones, they have a microphone built into them, and most of them are going to be Bluetooth capable. You can pair them up to your smartphone, and then all of a sudden, they're simply seen as a Bluetooth accessory using the hands-free profile according to the Bluetooth SIG, which means you can now handle two-way audio from the mic path as well as the receive path into the ears, and you have essentially a phone and phone call capabilities. And so these headphones also need to be validated for that. And again, that really falls into the bread and butter of the division that I'm in, the telecom and audio team, right? This is really a lot more sophisticated because with any telephone, you're going to see a lot more processing than on an audio device typically. And so this is really where things get gnarly and things get really hairy. But fortunately, telecommunications has been around for quite a while, and we've had a good head start at trying to develop test systems that can really account for a lot of the processes that we would see in telecommunications, voice activity detectors, AGCs, noise suppressors, echo cancelers, et cetera, et cetera. There's a lot of different processes that we need to account for beyond just things like spectral shaping, for instance. But typically in a Bluetooth scenario, one of the first things that happen when you pair your headphone to a smartphone is that it'll send, according to the Bluetooth SIG, a little string that says NREC equals 0. NREC is NREC. It's noise reduction, echo cancellation, 0. The headphone will send that command to the phone, say, I got this. Because the noise reduction, echo cancellation, that's typically something with acoustics. The idea is that the accessory will always know more about the acoustic environment than the main, let's call it just the modem, right? The phone is really just the modem communicating with the network. So then the biggest thing for the headphones is beyond just audio reproduction. How clear is the sound? Can you please make a pair of headphones that have a flat frequency response? That's great. But you also have to handle things like noise reduction and echo cancellation. That is the responsibility of the accessory. That becomes the responsibility of the headphone. And so we have tons of standards in the telecommunications world, ETSI and 3GPP and ITU and TIA and CTIA. There's a bunch of organizations that have slightly different focus, but they have standardized ways to do this. And we sort of pick and choose from the best of those standards to say, these are the most applicable test cases that we have for ANC headphones. And I think if I were to extract a few test cases to look at, I'd say from a very fundamental standpoint, we obviously want to characterize the sending direction or the transmit direction, because especially as a user, if you have the chance to go down to a store and try on a pair of headphones, it's very quick for you to understand, how does it sound? Is it spectrally balanced, frequency response? How's the overall level perception? You can hear those things. What you have a very hard time judging is your mic path, right? That's incredibly hard to characterize. And even for something like online reviewers, they're going to have to, team up with a buddy and then sort of communicate and figure out, do this subjectively. And this is where HEAD Acoustics has a test system. And so, especially for these things, we're very high on, you have to characterize the mic path, which is a little bit new for ANC headphone designers because they're mostly focused on the experience of the user. But part of the experience is you got to be able to make phone calls, and nobody wants the guy who joins a phone call and there's like zero noise suppression and he's standing in a metro station and there's just piercing train noise. Yeah. But we need his input and he's got to be on the call. Yeah. But he's using a poorly designed ANC headphone with no noise suppression.
In fact, Simon and I have a mutual friend, Kieran, and he does a lot of sourcing for ANC headphones, and he's constantly calling me from the Hong Kong metro station. And it's like, some of them work, and if it works from the metro, then he knows he's got a good product to start from, at least
otherwise it feels like you're there, right? Otherwise it feels like you're trying to have a business meeting in the metro station.
It's untenable. And there's a lot of people working, but so other things, like not only the mic pickup for the ANC or the voice, but also in terms of they're putting voice on the edge now. So voice commands in these headphones. Is HEAD's developing systems so that you can do that as well? I think your HEAD unit does all those kind of things. I mean, I've seen them in your units in the Amazon labs. So I guess you can just elaborate on that.
So that's kind of the next step, because you're right. Beyond just all the, let's call it human to human aspects of ANC headphones, there's also that human to machine component, which is like the speech recognition functionality that you touch on here. And with a lot of the edge processing with built-in command recognition, a lot of that can take place locally. You don't even need access to the cloud. But again, that needs to be validated and tested. And especially because a lot of these processes will function very differently relative to a human-to-human communication scenario. Essentially, it's really just a smart FFT analyzer. And one of the things that they look for is the spectral content and the patterns of human speech. For human-to-human communication, we just talked about it, standing in the metro station. I think you would probably be a lot more pleased if the noise suppression was fairly aggressive and cuts out a lot of the background noise in the metro station, even if it affects your buddy's voice quality ever so slightly. Right. For human to machine products, it's going to be almost just the opposite. If you have any type of noise suppression on that audio path, then there's going to be close to zero recognition because it's looking for the patterns of the speech, even if there's noise present. But if the noise suppression is affecting the speech, it could be very dangerous and could lead to really poor results. And so you can't just take one noise suppression algorithm and say, this sounds good, green light, stamp it, and apply it to all of our audio paths. So you have to, it's almost a separate tuning job altogether. But yeah, that's one of the things that we do at HEAD Acoustics as well. There's a few different companies that have programs for speech recognition testing. You mentioned one of them, but HEAD Acoustics, you can pretty much assume as soon as voice is involved, HEAD Acoustics is involved as well.
Okay, very cool.
But it's a very different animal to test to, because for speech recognition testing, it's a very open-ended scenario. You can go a million different ways with the type of commands that you want to use, type of dialects. We're all speaking a slightly different dialect. I have sort of a Danish, British, Canadian mix of Dave, Canadian, and Simon, New Zealand, Kiwi version. We all have different dialects that needs to be accounted for in terms of speech recognition. Whereas human to human, I mean, we can all understand each other, even if there's a different dialect. But does a machine, does an ASR interface understand the different dialects? That's one of the things you have to account for when you're doing speech recognition, which you don't really have to account for when you're doing, human to human voice and communication testing.
Yeah, those machine learning models to get accurate voice pickup, like from Google, or get certification from Google, is extremely difficult. Amazon's a little easier, but nonetheless, the sample size you need is, I think, typically like 10,000 samples will start to approach a good pickup or recognition. I have demoed some of these voice things with the Hong Kong accent versus a California accent, and it didn't work at all. So, yeah, it would have been useful had your unit been able to screen this before I showed it to the customer.
Yeah, absolutely. Right. Absolutely. So that's part of the whole test system. And from a very selfish HEAD Acoustics perspective, that's really what we offer our customers, is the ability to test all of these parameters. And ANC headphones happen to be one of the, kind of the unifying products for all of these different applications we talked about today. So it's really an interesting market, and beyond just the fact that I feel like it's a product that most people understand and grasp and maybe even own, so there's a good sense that when you talk about this thing that people get it, It's not as abstract, or maybe it still is abstract when you talk about Moss metrics and psychoacoustics, but kind of the beautiful thing about audio is it's a very visceral experience. And if you have any doubts, listen to it, tell us what you think. A lot of people subjectively review it, but likewise during the design phase, there's still that little bit of art. You still got to listen to it. And as a consumer, you'll know what 30 dB of attenuation sounds like if it's properly implemented, or whether it's, marketing dB. You'll know the difference. You can hear the difference.
Right. And so, like, just some kind of like administrative notes, I guess. For the business model, you guys sell the head units. You offer consultancy services as well for, if it's a mobile phone startup or a Bluetooth headphone startup, they reach out to you, and you guys have different packages to offer them, I suppose.
Correct. We basically have two different ways of doing business with our customers, and one of them is equipment sales, technology sales. We allow our customers to do this testing on their own, and then we have a very fleshed out, very experienced engineering services team, essentially consultants on staff that own all of our equipment we can either airlift them onto your site to take care of the job there, or you send them products and some instructions on how to operate them, and then they can do the testing and tuning job. So it kind of addresses most needs when it comes to headphone development and the different applications surrounding something like an ANC headphone.
Okay. Simon, do you have any questions?
I'm just curious about the mic path thing. We talk about the ANC metrics in terms of the Zwicker loudness or various other ways of characterizing it. Do you have a similar approach for the mic path? That is to say, some metrics that people are not using quite as widespread.
Yeah, absolutely. So it's a good question, because on the mic path, I think we would probably rely on 2 or maybe even 3 different MOS metrics, mean opinion scores. These are all scores that have been created based on jury studies. Mm-hmm. And the role of a MOS metric is essentially that you feed it an audio signal, and then it's similar to asking 300 people for their opinion. Mm. And then you get an aggregate of those 300 people, but you use a metric and you get the result in 2 seconds. Yeah. And so a very common one that's used in voice and telecommunications is something called Polka, standardized in ITU-T P863. And Polka works great for evaluating the speech quality, both in the mic path direction and in the like in the receive direction, but crucially does not work in the presence of background noise. So yes, it can characterize the headphone in a quiet condition. So for what we're doing here, yeah, we could probably do that. But as we talked about, people are on the move, they're at the metro station. There's no way to use Polka for that scenario, but we do have a different metric, something called 3Quest, which is a kind of a threefold quality metric that evaluates not only the speech quality component, but also the noise suppression or the noise reduction component. And then it also gives us an overall global quality score. So it's similar to Polka in that sense that we evaluate speech quality, but it's a lot more sophisticated and also addresses the noise suppression. And then there's additional one called eQuest, which is the echo quality. Mm. And so when you talk about echo and the kind of the loop back of your own voice and things like that, we can look at it spectrally. We can look at it in the time domain. We can see if the echo canceller is taking a long time to converge or what the situation might be. But ultimately, what we really want to know is how annoying is it? How bad is it? We can get, dB numbers and activation times and things like that. But we really want to know on a scale of 1 to 5, how much are people going to care about this? And that's in some sense what the eQuest metric does, based on jury study, based on training an algorithm around what people really have reported to us in the case of this jury study. So there's plenty more metrics, and we could probably spend another couple of hours talking about that. But suffice it to say, if people want to learn more, they can reach out to us, and our website is fairly comprehensive and has some different tools and spec sheets that they can use and look at. And then, we'll be happy to follow up with them one-on-one if that's of interest.
All right, so we'll send them all to the German head office so they don't bother Jacob. But just kidding. We can we'll put the contact info in the description below. And Simon, do you have anything else you want to?
I got one more quick question, Jacob. Do you have an opinion on whether there exists a good metric for specifying an ANC headphones level? Because for the moment, people mostly put up their peak point and optimal situation. Is there another way of doing it?
In terms of
so consumers can see a number and say this is better than that. Do you think there exists such a thing?
Not yet. Not a single number.
Yeah.
That's always the problem with a single number. Even with things like MOS metrics, you get a single number, a quality predictor, but it doesn't necessarily tell you why it's bad or why it's good. It's just it's good or bad. Same thing with a dB attenuation number. The more you reduce your amount of data and display it to the consumer, the more you also lose. And the one thing I'm sure of is a single dB attenuation number is not the right number.
Definitely.
It's useful, it's important, but it's not everything.
Yeah.
And it's not the right number. So great question, but maybe that's a future discussion topic.
Yeah.
All right. Okay, so thank you, Jacob, for joining us today. We really appreciate that, and maybe, just maybe, we'll see you at Barry's ambitious Alti show coming up in October.
Yeah, and I hope to be there.
Okay, so all right, everybody watching, please do the usual, like, subscribe, and hit us with your comments. Don't be shy to ask questions. Simon can help, and I'm sure we can pass them on to Jacob if it's really juicy. So thanks everybody for watching. Have a great day.